Alrighty, what's up everybody? We're going to go ahead and talk about simplifying radicals. So the first thing I want to note is that a radical is basically this symbol that you know and love. It's the square root sign. And in today's lesson, we're trying to learn how to simplify radicals. And yes, you do know what the word simplify. It's another word for reduce, or trying to make your answer look better when you're trying to reduce fractions or something like that, right? So before we begin, I want you to go ahead and take a look at this over here. You need to know and you need to remember prime factorization. We need to break up a number, and then we're going to see two numbers that multiply together, and we're going to keep on breaking numbers until we have prime numbers, right? And we need to do that involving variables as well. If I have something like x squared, you know for sure that the two something times something x that's going to give me x squared is x times x, right? You need to know something like that. And you need to make sure that you're organized. Your handwriting is legible to see, because you need to keep track of the repeated numbers. If you make one mistake, your problem is going to be incorrect. You need to make sure that you have some sort of organization here in order to succeed in doing this. And with simplifying radicals, we're trying to get something that's exact, and we don't want to provide decimals in our answers, because decimals tend to be ugly and not it doesn't look good. So we want to make sure that we simplify radicals. We're going to give the exact answers and just make it overall make it look nice. Okay, so we all know that the square root of 4 is just 2. And why does this work? Okay, the square root of 4 can be rewritten as the square root of 2 times 2, right? 2 times 2 is what? 4, right? We can break that up. Or you can write this as the square root of 2 squared, right? 2 squared is the same thing as 2 times 2. Exactly what we have here. Now, the thing about the square root sign and some value raised to the second power, okay, if it's all alone or multiplying and there's no addition involved like that, right? Only alone like this. I'm not going to confuse you, but just focus on the square root of 2 squared, okay? The thing about this and this, they undo each other. They get rid of each other. They literally just, when they fight, they die. They both die, basically. And it's pretty dark, golly. So this thing goes away and this thing goes away. It's like, when you're trying to do a basic algebra problem from first semester, and still now, you have like x plus 5 is equal to, 10, right? There's this, you're trying to get x by itself, but there's this positive 5 here, right? Plus 5, what's the opposite of, positive 5 or plus 5? Well, that's just going to be negative 5, right? The opposite or the inverse operation of addition is subtraction, and the inverse of subtraction is addition, right? Vice versa. That's basically what's happening here. The square root and the number 2 or the exponent of 2, they just don't like each other at all. And that's why they go away, and you're going to get 2 by itself. Okay, I think I explained myself way too much for this problem, but hopefully that you understand. If you're having troubles, following on with what I just said, you can go ahead and read the rule that I wrote over here. Okay. We're going to go ahead and talk about the buddy system. The buddy system, it says, after prime factorization, pair any two of the same numbers together. Okay, this is what I'm telling you. I need you to be organized. I need you to make sure that you're able to keep track of what the heck is going on when you're doing this. Move one outside and eliminate the other. That's when you're pairing. Repeat until there are no more pairs. If a number doesn't have a pair, it remains inside the radical sad, potentially with other numbers that don't have a pair. Dang, this is pretty sad. Okay, here we go. Let's take a look at the example above, right? The example above, I'm referring to this over here. There are two numbers that are the same, right? So we take a look at the square root of 4. Actually, don't look at this example. Look at this example. There we go. And I'm like, okay, two numbers that multiply together to give me 4, right? 2 and 2. And you see that, okay, I have two of the same numbers, I'm going to go ahead and circle that. And I'm going to move only 1, 2 outside of the radical sign. All right. Do I have any other pairs here? I don't see anything here or anything. The only thing that I have are just pair of these pair of 2s, and one of them goes outside and one of them remains in, or not, I'm sorry, not, it doesn't remain anywhere. It's just one of them goes outside and the other one just gets eliminated. This goes outside, this one gets eliminated. And there's nothing in the there's nothing in the radical sign. And since there's nothing in the radical sign, then it goes away. So this is right here. Since there are no number inside, the radical disappears. So the answer to this equation is 2. Or, sorry, the answer to this question is 2. Okay. Yeah, and exactly this is what we have here. Okay. Before we begin 2 more examples, be sure to prime factorize. Multiply any numbers inside of the radical. Multiply any numbers outside of the radical. A single number under the radical will be kept alone. If no number inside the radical, then the radical itself disappears. All right, let's do the buddy system again. Not really a buddy system. It's pretty, it's pretty fake, but okay. We have the square root of 2 times 2 times 2. This example is already factorized, so I'm going to go ahead and pair up the numbers that are the same. Only, a pair means 2, so I'm going to use the color red. I see that there's a pair of 2s. One of them is going to go outside and the other one's going to get eliminated. So I have 2 times the square root. Yes, this is multiplication. 2 times the square root is the same thing as this, okay? And then, does this 2 here have a pair? No. If it doesn't have a pair, it's going to remain inside the radical sign all lonely. And this is my answer. Okay, hopefully that this is making sense after you looked at the first example. This is already prime factorized, so please keep note of that. How about this one over here? Okay. We have the square root of 81 times 7. So this example contains a perfect square and a prime number. You could be tempted to go ahead and multiply this, but that's just way too long. So this is already given to you. So just appreciate the fact that this is already given to you so that you can do the problem much more, efficiently and faster, and it's easy. So we could do prime factorization, or I could tell you that you can rewrite this as the square root of 81 times the square root of 7. They are the same thing. Okay, and we know that the square root of 81, is just 9. And then the square root of 7, this right here is a prime number. I can't break that down. And it doesn't have a pair. It doesn't have a buddy at all. So I can go ahead and just leave that as my answer. Okay? Or you can just go ahead and if you don't know what the square root of 81 and you want to use that buddy system, so let me rewrite this. So I have the square root of 81 times the square root of 7, right? And I know 2 numbers that multiply together that gives me 81 is 9 and 9. And since, I have a pair of 2 9s, one of them goes outside of the radical sign and then one of them gets eliminated. And then I'm just left with what? Nothing else. So that radical sign disappears as well. So I'm left with 9 times the square root of 7. And again, that's exactly what we have here. Okay? Hopefully this is making sense on what's going on. And by the way, you don't, if you want to do this faster, you don't have to do an X. You don't have to eliminate. You can just go and circle and move one outside of the radical sign, and then it's just going to disappear if you have nothing left, or if you have no pairs left. Okay, let's go ahead and do number 3. This one deals with prime numbers and variables. So let's see. Let's go ahead and circle our pairs. I see a pair of 3's and I see a pair of x's. So what does that mean? Well, 1 3 is going to go outside of the radical, and then 1 x is going to go outside the radical as well. So if I have 2 things, or if I have more numbers outside of the radical, make sure that you separate with a multiplication sign. So this is going to be 3 times x times the square root of what's left. Well, this number here doesn't have a pair, it doesn't have a buddy, so it remains sad inside of the radical sign. So the answer to this question is 3x times the square root of 5. And that's my answer. Okay, so now let's go ahead and take a look at the square root of 52. All right, so the square root of 52, you know for sure that is not a prime number. It's not a prime number. So what do you have to do? Break it down. Prime factorization skills here needed for this. I need 2 numbers that multiply together to give me 52. Well, I'm thinking 26 and 2. And then let's see, is 2 a prime number? Yes. I can't break that down. What about 26? Can I break that down? Yes, I can. 13 and 2, and we know that for sure that this is a prime number, but what about 13? 13 is also a prime number, so I can't break that down. So then that means I can stop and look at this, and I'm like, well, I got a pair of 2's. That means that one of them is going to go outside of the radical to play, the other one gets eliminated, and then what's left? That 13 remains in jail. The square root jail, just like that. That's my answer. The square root of 18, we know for sure that is not a prime number, so you can break that down. So 2 numbers that multiply together give me 18, 9 and 2. Is 2 a prime number? Yes. Is 9 a prime number? No. You can do 3 times 3. A lot of you, I don't know why, a lot of you think, 3 times 2 is 9, which is not true. 3 times 2 is 6, so that's wrong. Don't make that mistake, please. Okay, these 3's are prime numbers, so that means that I'm done, and I can go ahead and just circle that and bring 1 3 outside of the radical sign. And then what's left, what's lonely, is this 2. So there you go. Okay. There you go. Let's do the square root of 125x squared. So we know for sure that 125 isn't a prime number, and x squared is not a prime number. So let's break down the 125. I'm thinking 25 and 5. And then I can break down the x squared, which is just x times x. So can I break down this x? No. Can I break down this 5? No. But can I break down this 25? Yes. So I can go 5 and 5. And then I'm going to go ahead and circle my numbers that have a pair. So this has a pair, this is a pair, and that is a pair. So that means 1 5 goes outside of the radical, and 1 x goes outside of the radical. And then what's left is just going to remain as is. So I have 5x times the square root of 5. This is my answer. Okay? All coming together, yes, hopefully. Okay, here we go. Let's do this one. The square root of 45 times y cubed. 45 isn't a prime number, so I can go ahead and break that down. So I have 5 and 9. And then this is 3 and 3. And this y cubed is y times y times y. So let's go ahead and circle our pairs. So here's a pair here. Here's a pair here. And then I'm going to write 1 3 outside of the radical sign and 1 y outside of the radical sign. and then whatever remain as is. Please pay attention to this. Whatever you have that don't have a pair, or that doesn't have a pair, I'm sorry, you put them under the radical. So you see this 5 here, it goes in the radical. And you see this y over here that also goes under the radical, and they're going to be multiplied. Anything that is under the radical that, you know, that don't have a pair, they're going to be multiplied. If this was like a 2 and there's not, and this 2 doesn't have a, you know, have a buddy, then it's just going to go in here and it's going to be multiplied by that 5, and that's just going to be 5 times 2, which is 10. But in this case, we're dealing with y, so you're going to be done here. Okay, here we go. Here's the next problem. 8 isn't a prime number, so let's go ahead and break that down. I have this, I know that's 4 and 2, and then this is 2 and 2, and this right here is n times n times n times n times n, right? So let's see. I have a pair of 2s, pair of n's, and another pair of n's. So how do I write this? So I have this negative sign. Okay, there's a negative 1. This right here is a negative 1. So I have negative 1 times, so I take 1, 2, and multiply that by negative 1, and I have a pair of n, so I multiply that by n, and then I have a pair of n again, pair of n's again, and I multiply that by n there. So then I write my square root, or draw my square root, or whatever, and then put whatever remain inside the square root. So here's this 2, so it goes inside the radical, all sad and lonely. What else do I have? And I have this n over here. It's going to be sad and lonely. Not really has a buddy, but they're not gonna match. They're not gonna be in love with each other. So whatever. Let's see. Negative 1 times 2. That's just negative 2. N times n is n squared. And you put the square root of 2n. And that's your answer. So basically what you're trying to do all this time is, you know, find a match. You know, pair up with someone. Be in love. We'll move you outside, and we'll have your buddy, you know. Yeah, this is pretty dark. I don't know anymore. Okay, well, all right, let's go. And by the way, you can check your answers too with the calculator. Compare the original problem to your answer and see if you have the exact value. Okay, you can do that. So, simplifying radicals involving fractions. Suppose that you have, let's say, the square root of a over b. Okay, you can rewrite that as the square root of a over the square root of b. That's totally fine. And then you'll apply the same, you know, rules that we've done before. So if you take a look at the square root of 1 over 36, you can write that the square root of 1 divided by the square root of 36. And the square root of 1 is just what? 1, and the square root of 36, well, what are the two numbers that multiply together give me 36? 6 and 6, yes? So I put, you know, I got a pair, one of them goes outside, and we don't have anything else, so the radical sign goes away. So that's just going to be 1 over 6, and this is my answer. Okay? This can be rewritten as the square root of 3 divided by the square root of 25. Well, do I know what the square root of 3 is? Is 3 a perfect square? No. So I don't do anything with that. And then we look at the square root of 25. We know that the square root of 25 is what? Two numbers that multiply together give me 25. Well, 5 and 5. And then, you know, one goes outside, the other one gets eliminated. So I'm having the square root of 3 over 5. This is okay. This is my answer. Oh, that's so ugly. Hold up. Fix that. There you go. That's beautiful. Here we go. The square root of 81 over the square root of 8 squared. Can rewrite that as the square root of 81 divided by the square root of 8 squared. The square root of 81 is just 9. And then, you know, I told you at the beginning, if you have a square root like this, and, you know, some value being squared, and there's no addition or subtraction involved, then what you can do is that you can just cancel that out because they undo each other. They fight each other and they both die. So this is going to be 9 over a, and this is fine. That is my answer. Okay, here we go. We have negative x cubed over 49. Okay, here we go. So this can be rewritten as negative times the square root of x cubed, and then all over the square root of 49. Now, the square root of x cubed can be rewritten, or you can break that up as x times x times x, right? We have a pair of two x's. One of them goes outside, and the other gets eliminated. So we have x times whatever we have left, which is just x. So we know for sure we're going to have negative. Don't forget that negative sign. That's being multiplied. Negative times x, which I got here, times the square root of x, divided by the square root of 49 is just 7. This is your answer. Okay, there you go. Now, what if you have a radical in the denominator? In the law of math, it's illegal. So 9 over square root of 45, you can't have this as your answer because you have a radical in the denominator. You need to get rid of it. And how do we get rid of it? Well, I need you to remember something. We know that the square root of 2 times the square root of 2 is the same thing as the square root of 2 times 2, which is the square root of 4. Right? And that's just going to give me 2. Because we know that the square root of 4 is just 2. Basically, if you have a square root of 2 and it's multiplied by itself, it's just going to be the same number. So we take a look at the square root of 45 over here. All I got to do is I need to multiply that by the same number, the square root of 45 times the square root of 45. That's just going to give me 45 in the bottom. And then whatever you do on the top, you got to compensate. You got to do that. Whatever you do on the bottom, you got to do on the top as well. So I got to multiply that by the square root of 45 as well. So what am I left with? 9 times the square root of 45. Is this my answer? No, this cannot be your answer because you got to make sure that you simplify even further. Remember, we have to make our problems look nicer. Let's take a look at the square root of 45 again. The square root of 45, let's break that down. 5 times 9. 3 and 3. One of them goes outside of the radical sign. So I'm left with 3 times the square root of 5. So rewriting, I have 9 times, well, the square root of 45. If I simplify that, it's going to be 3 times the square root of 5. So that's going to be 3 times the square root of 5 all over 45. And then, okay, so it's all outside of the radical. These are multiplying. So I'm left with 27 times the square root of 5 over 45. Okay, I'm going to move this. I'm going to move that. Let's see where can I move that? I'll move that over there. Okay. And, you know, we got to take a look at this even further. Can I reduce this? Can I reduce this? Yes, I can, because I know for sure that 9 goes into 27 and 45 at the same time. So that means I got to divide everything. Not everything, I'm just kidding. I need to divide this by 9 and divide that by 9. So 27 divided by 9 is 3. And then I have that square root of 5 left over. And then 45 divided by 9 is just 5. And now this is my answer. Okay, go ahead and take a look at the notes. Remember to reduce, because we are still dealing with fractions. We can cancel a number in the top and bottom. Remember, if you have something like this, if I have something the same up top and the bottom, I can go ahead and cancel that out, because it's like saying 5 divided by 5. That's just 1, right? The square root of 5 divided by the square root of 5. You know, anything divided by itself is going to give you 1. And remember that you can also do this, right? 5 times 5, or I'm sorry. Okay, so we can cancel this and this, right? Because 5 times 5 divided by 5, 5 times 5 is 25 divided by 5. Well, 25 divided by 5 is what? 5, right? Is this exactly the answer that you look for, or you're looking for? Yes. Okay. If you need more examples, go ahead and scan this using your phone. Alrighty, if you have any questions, let me know. Bye.